morning. In our lesson today, we are going to talk about Introduction to Computing with our substrand, Generation of Computers and Part of a Computer and Other Gadgets. Under Part of Computers and Other Gadgets, we are going to discuss digital and analog devices. Let us look at what a digital device means. Digital devices are devices that uses binary code or binary digits, that is, zeros and ones, to represent data. So any device that uses binary code to represent data is an example of a digital device. The binary digit is the smallest unit of data that a computer can process and store. And this is what the digital device uses to represent data. And it comes in the form of zeros and ones. The zeros and ones are known as the machine language. This is the only language the computer understands or the computer can work with. So whenever we enter something onto a computer system, it is converted into zeros and ones. That is the binary digit, so that the computer can work on it. And these are the electrical on and off signals that process data. So, digital devices are devices that uses binary digit to represent data. And we shouldn't forget that the binary digit is in a form of zeros and ones, which is the on and off signals that process data. Examples of digital devices. Computers. So computer is an example of a digital device. Mobile phones, tablet devices, digital television, smart watches, digital cameras, scanners, printers, projectors, etc. Examples. So we can see the examples on the picture. We can see desktop PC, digital camera, MP3 player, iPad, mobile phone. All these are examples of digital devices. And the devices represent data using a binary digit. That is the zeros and ones. Let's talk about an analog device. After this, I will give an example of a real-world scenario to explain how digital devices and then analog devices works. An analog device uses continuous range of values to represent information. These devices represent data in terms of physical quantity or measures. Now, when we were discussing digital devices, I said that digital devices uses only binary digits to represent data. But in the case of analog devices, the devices represent data in terms of physical quantity or measures. And then it uses continuous range of values to represent data. So we can see the differences between analog devices and then digital devices. One uses binary digits, that is a digital device, and then analog devices uses physical quantity or measures, which is a continuous range of values to represent data. Analog devices have the ability to record, measure, broadcast, and reproduce continuous data. Therefore, it has continuous signal that can have an infinite number of values. So an analog device has continuous signal having an infinite number of values. Examples of analog devices. We have the speakers, cassette, analog watches, tape recorder, microphone, scale balance, analog thermometers, etc. All these are examples of analog devices, that is, devices that represent data in physical quantities and measures. So we can see some of the examples. We can see television. We can see headphone speakers, thermometer, and then the microphone. All the devices can use physical quantities to represent data. Let's talk about the similarities of analog and digital devices. We can say that both devices require data. So it is clear that both devices require data. Whether analog or digital, there will be the need for data. We can also say that both have been used in a variety of applications, including scientific simulations, control systems, and data processing. We can also say that both devices are used to convey information. And then the devices have a frequency and amplitude. Both signals are not static. So all of these are the similarities of analog and digital devices. Let's talk about the differences. Now, it is clear that analog signals are continuous signals, but digital signals are discrete time signals, as I explained. The second is that analog signals are sine waves, but when we talk about the digital signals, we can say that the signals are square waves. Analog signals have a fixed range of values. Analog signals have a fixed range. But when we talk about digital signals, we can see that digital signals are not fixed. So practically, we can say that human voice is an example of analog signal. But when you take the computer signal, we are saying that the signals are an example of digital signals. Let's start with the human voice. When you speak, your voice creates a sound wave, which is a continuous physical wave. This sound wave is an analog signal. A computer, on the other hand, only understands digital signals, which are made up of zeros and ones. So when you speak into a microphone connected to a computer, the microphone converts the sound wave into a digital signal using the ADC, that is, analog to digital converter. By measuring the amplitude of the sound wave at regular intervals, the digital signal can then be processed by the computer because the signal has been converted into digital data. Now, let me give you another example. If you take a string of bead, I want to use a string of bead to explain how digital and analog devices works. If I have a string of 10 beads and the first 5 beads are red and the last 5 beads are blue, I can't move the beads around. I can't take one of the red beads and switch it with one of the blue beads. This is how digital information works. It is fixed in place and can only be manipulated in certain ways. So when we talk about digital information, the information is fixed in place and can only be manipulated in certain ways. That is, in binary digits. Now let me use marbles to also explain how analog devices works. If I collect 10 or 15 marbles, I will see that the collected marbles can be sorted by color, size, or any other characteristics. This will be like the analog information, since it can be sorted in any way. So with digital information, we can only represent it in the binary digits. But when we talk about an analog data, the data can be sorted in any way. I hope we get the meaning of digital and analog devices, and then the differences and similarities of analog and digital devices. Now, if you have any question to ask, you can use the comment section to ask all questions. But before we end the session, let's do a short exercise. Question 1. Differentiate between analog and digital devices. 2. State 2 similarities between analog and digital devices. 3. State 2 differences between analog and digital devices. So you can use the comment section to give your responses. Thank you. See you in our next section.